Hey, good afternoon. Welcome back to the final session. We've talked about the history of Ethernet, and wasn't that fascinating? We've talked about where Ethernet fits into everything. We've talked about where Ethernet is today, and now we're going to talk about the future of Ethernet. So, without further ado, as has been said before, let me ask David Newman from Network Test to come down and tell us something about that. David.
Thank you, and good afternoon. We're going to have a stellar panel on this session to discuss where we're headed. And one of the things we've been hearing all day is that this question of what is Ethernet. So although we'll be talking about the future, I thought we'd begin by talking about where we've been and what that might tell us about where we're headed. So with apologies to the panelists, any panelist who's going to boldly predict that Ethernet will get faster, here's the rate track for Ethernet, and it's a good example of the way that Ethernet keeps reinventing itself, where the original Ethernet ran at about 3 megabit, and today we've got 400 gig Ethernet under study in the IEEE. And every new generation of Ethernet that comes out, the old generation is a rounding error compared with the new version. In fact, that was the joke among Ethernet's inventors, was that the old 56K lease lines that Ethernet replaced at Park, that was literally the rounding error between the nominal, the nominal 3 megabit rate and the actual rate of 2.94. And so there's been this steady and exponential progression in rates. So to the question of what is Ethernet, we cannot describe it in terms of rate alone. So, click, click. If we can't describe Ethernet in terms of rates, what else can we say about it? The original Metcalfe and Boggs paper described Ethernet as a system of local communication among computing stations. Well, we've had Metro Ethernet for more than a decade, and there are some WAN implementations as well, so that's out. When I was a young network manager, I often heard Ethernet dismissed as a science project, and I was told I should go learn serious network technologies like Token Ring or something else, because that would be the corporate standard. And as we all know now, Ethernet pretty well trounced Token Ring, not only Token Ring, but pretty much every other competing technology. So that's out. Service providers used to complain that Ethernet was somehow not good because it was unmanaged. Today, those same service providers are busy implementing Ethernet OEM, so that's out. Other network managers used to complain that Ethernet was somehow not good because it was somehow not predictable or not reliable. Today, we have things like resilient packet ring in the WAN, and priority-based flow control in data centers that give us very reliable, very predictable service levels over Ethernet. So that's out. And this final point comes already struck through. Ethernet was never expensive. It's always been cheap to build, cheap to implement because of its simplicity. And that brings me to a word that is intrinsic to the past, the present, and I think the future of networking. That word is money. Bob Metcalfe, before he moved to Texas, lived in a very grand 6-story townhouse in Boston, and he often had students over to visit. And the students would walk around this great house all glassy-eyed and go, wow, I've got to work really hard to invent something really cool so I can live in a house like this. And Dr. Metcalfe would tell them, you don't understand. I don't live in this house because I invented Ethernet. I live in this house because I learned to sell Ethernet. So I'll just put up this quote that no engineer likes to see. But the fact is that financial factors have always been a part of driving the history of networking forward. And although we'll have a lot of technical talent on our panel today, I'm hoping that we'll discuss both technical and business drivers when we consider what's to come next when we look at Ethernet. So with that, I'd like to ask our panelists to come up now. Oops, sorry. And please join me in welcoming them up. They are Faraj Alai of Aquantia, Stu Bailey of Infoblox, Glenn Edens of Park, Bruce Davey of VMware, and Shazad Merchant of Gigamon. Welcome all. So I'd like to start off by asking each of the panelists to give us a very brief 1 to 2 minute introduction on his view of what's interesting and what's new in networking and where we're headed. Then we'll open up the panel to some discussion, and we'll finish up, as with the other panels, with a Q&A session from the audience. So let's start off immediately to my right. Bruce, with you, if you'd like.
Sure. So I think there's obviously a lot of things I could say about the future of networking, but the one that is really pressing for us right now is the virtualization of networking that came up in some of the earlier sessions. And if you know anything about VMware, you probably know that VMware really made a business out of server virtualization, and interestingly, didn't invent it. It was invented, I think, by back in the 70s at IBM. But VMware made a business out of server virtualization, and the piece that's really been missing for I'd say the last, well, I guess as long as there's been server virtualization, is an equivalent technology for virtualizing networks. And so that's the big thing that we're working on now, is trying to make it possible to create and manage networks that are created in software and can be provisioned in seconds, just the same way you can create and provision applications in software today, running them in virtual machines, separating away the network services from the underlying physical hardware. So it's this separation of network services from hardware and speeding up the provisioning time that network virtualization enables. So I think I've used my minute. I'll leave it at that for now.
At Park, we're working in a number of network technologies, hopefully in the tradition that we started, but it's a tough thing to live up to for sure. One of our most significant projects is around content-centric networking, which is focusing on what would a network be if content and its name and how you get it is more important than machine addresses. So we're working on a set of technologies that basically explore that space. We've done a number of very interesting proof of concepts in the area of content distribution networks and some other applications. But it's pretty interesting to imagine an internet where you didn't have source and destination addresses and you really concentrated on the, well, I understand, you concentrate on what we kind of think is the primary use of the internet until I understood it was about shoes.
I'm Stu Bailey. So we're a little bit unique, Infoblox. We're actually a public company that for 10 years, more than 10 years, has successfully sold independent software into the networking business. So that is traditionally just not true about networking. You sell a box, it does something. And because of the work of the people in this room and what James Walker mentioned in the panel earlier, Ethernet really is ubiquitous. And so that changes the potential economic model for this hardware-defined networking industry, which has served us all very well. But that paradigm shift, which means that really an independent software market could emerge in networking, and that the center of value, as it did as we transitioned from the mainframe to the PC server, the center of value shifts from hardware to software. That seems fundamental. And so as an independent software vendor, one of the few in networking, we're very focused on how that will transform over the next few years.
Hi, I'm Shazad Merchant from Gigamon. First of all, I'd like to say thanks to the organizers for setting up a fantastic event to celebrate 40 years of Ethernet. It's truly an honor and a privilege to be here with all these people here. It's interesting, if you think about the future of networking, to really look back a little bit and try to see what's changed over the last couple of decades and what has not. Right? So if you look at what's not changed over the last couple of decades, is the fundamental nature of networking still, I think, by and large stays the same, which is you have network equipment that is still vertically integrated. Right? You got hardware, you got silicon, you got control systems, operating systems, application stacks, all coming from the same vendor. And I think as you look to the future, the first thing we're beginning to see is that vertical disaggregation. And I think that will give rise to a tremendous opportunity to innovate, where you'll have a set of vendors providing hardware, and there'll be innovation happening there. A different set of vendors providing the control plane software, and there'll be innovation there. And then another set of vendors providing applications, and there'll be innovation there. So that's, I think, a tremendous opportunity. Now, if you look back and say, what does all of this require? I think this is going to give rise to a completely different kind of a network that is going to be critical for instrumentation, for visibility into what's going on. Right? As you take these different layers and try to figure out, how do I troubleshoot this? How do I manage this? How do I instrument this? It's giving rise to a new kind of a network called a visibility fabric or a visibility network. This network is very different from how silicon is designed today for traditional networks, which is address-based forwarding. Right? You take a packet, the address, you send traffic. When you start thinking about instrumentation and visibility, it's a very content-based forwarding paradigm. So it reflects what was just talked about, right? I think there will be a growing need for a content-based forwarding, particularly when it comes to instrumentation and manageability as the network disaggregates, so to speak. So I think that's a tremendous opportunity moving ahead.
Hi, my name is Faraj Jalai. First of all, I'm going to yield most of my time to you because you're going to have a wonderful conversation going on here. But the one thing that I can say for certain throughout this panel is everything these gentlemen are going to talk about is going to have to ride on a physical layer technology. And that's what our company does. We build 10 gigabit Ethernet over copper, 10 GBHT. Our goal as a company is to keep moving the legacy of Ethernet forward. There is a phenomenal number, about 1 billion ports of gigabit Ethernet that ships every year. Our goal is to convert all of those gigabits to 10 gig Ethernet so that every consumer can have access to that broadband Ethernet flow so they can exchange their movies and whatever traffic they have.
Okay, great. Thank you all. So we've heard some differing visions here about, there's consensus that we're moving more toward a software-based model of networking, and maybe some differing versions about the software-hardware split. So let me start off by asking anyone on the panel, what are your views as we move to this more software-based world? What are your views on how that affects the installed base of Ethernet hardware that's out there, and how does it affect new Ethernet or new network implementations, be they virtual or physical? Anyone?
Everybody's looking at me. So I've learned I have to be very careful because at VMware we partner with almost all the hardware companies, so almost anything I can say can be taken to offend somebody that we work with.
Speaking for yourself.
Yeah, speaking for myself. I think that clearly as we start putting more of the complex services into software, that means that there's a focus on different things from the hardware than has been the case in the past. I think it used to be that you looked to get all of your complex services from the hardware and you would compare one box against another based on the complexity of its feature set. Now I think it's going to come down to more about how easy is it to manage that hardware, how resilient is it, how well does it self-provision itself. So this, as was said a few minutes ago, the hardware continues to be critically important, but I think the set of things that people are going to use to evaluate hardware will change away from complex features and more towards things to do with manageability and resilience and performance.
If I may jump in real quick, I fully agree. I think what we're really looking at here is a paradigm shift, right? Where this disaggregation happens and people are focusing on software and control planes, and there's always going to be hardware as well. But a paradigm shift typically is embraced when it is easy to embrace it, right? And you need, what I would say is you need tools, you need instrumentation, you need visibility into every layer of the stack as you think about this paradigm shift, right? Any new technology is significantly, and the adoption of any new technology is significantly enhanced if you have the ability to troubleshoot it and to manage it, right? So I think as we look at this vertical disaggregation, as we look at applications and a greater emphasis on software, the ability to look into that, to look into the applications, to look into the control planes, to look into the physical networks will be pretty critical in enabling that disaggregation.
Yep. So our perspective, we're software people. So we're not hardware people. And in fact, I brought some props, and I was very warned, like, you cannot bring any products. And it's easy for us because we don't sell any networking gear.
Hardware.
Right. Yeah, this is not hardware we would sell.
Someone else's hardware.
Yeah,
That's
someone else's
okay.
hardware.
Yeah.
We won't tell who it is. And Infoblox doesn't sell packet processing stuff. We sell software. Sometimes we ship it on a white box server, but it's not packet processing stuff. But I'll tell you what excites us. This is a just off-the-shelf box with 1 gig Ethernet ports, and with software, I can turn this into what's called an OpenFlow switch. And if you're not familiar with OpenFlow, that's very exciting for us software people. That is a way to turn this white box, after it's been deployed remotely, into either a firewall or a load balancer or a router or some combination of those things that's actually tailored to a business need. And this is like 4 ports of Ethernet. You can buy it off the shelf, and it's giggy, and it's $400. And we assume that price will only get better. I don't know if you've ever heard of a Raspberry Pi, but this is a $35 ARM processor-based board, $35 retail, and it comes shipped with, on it, 100 megabit Ethernet. So again, thank you to everybody in the room. And you can put a Wi-Fi card on the USB. You can put more than one. So now I have more than one network port. And for me, I'm a software person. We're software people. I don't know what's really going on underneath the card, but it looks like Ethernet to us. Exactly what was said in the last panel. The frame is what's important to us. So now we have two pieces of hardware, which are Ethernet data planes, and remotely, at any time, I can change the packet processing functions in those data planes, and that is fundamentally with software, using OpenFlow. So now that Ethernet is ubiquitous, OpenFlow becomes a standard for software-focused people to, imagine 10,000 of these switches. Now, as a software person, I have a standard way without touching the hardware to turn these into any kind of box function I'd like. That seems fundamental to us, and we think that will be increasingly fundamental to our customers because it just changes the economics.
If I may, I think that's a fantastic point you bring up, Stu, right? I think as we start thinking about software and programmability, right, another aspect which is adjacent, but I think equally important, is the notion of programmability, right? And I think that's going to be pretty critical as we think about evolution or discontinuity in the way we think about networking. One of the things, again, if you look back, one of the things that has not changed over the last decade, 2 decades, is the kinds of APIs that are available for network developers. How many over here are familiar with APIs like get time of day? Anybody written SQL? There you go, right? Get host by name. Right? People still think in terms of IP addresses, MAC addresses, right? And that paradigm hasn't changed over the last several decades. So I think there's an opportunity as we think about a more software-centric networking for content-rich APIs, right? And what I mean by that is the network sees it all, right? You have visibility into who the users are, where they are, what they're doing, when are they getting on the network. But that information is not easily available today. It's all IP addresses, MAC addresses. But if you can start thinking about content-rich APIs, get user by name, things like that, I think you have a complete paradigm shift in the making over here.
So that brings up an excellent question for Glenn and for whomever else as well. How does content-centric networking change the model? How does it use the existing addressing model? Everyone needs a name. And how do we get away from that, or do we get away from that?
So there's a couple interesting factors. It is possible to build a CCN-based network or a content-accessible network without any IP addresses whatsoever. And we've proved that. You basically get into some interesting discussions on how you route on names, but the key thing is you're dramatically increasing the flexibility of routers by making them include a great deal of memory. So distributing caching and distributing computing into the router are the really key elements to running a large-scale content-centric network. One of the things that happens is you change the kind of processing you do. Rather than worrying about how quickly you can map addresses through address tables and content addressable memories and cut through on a router, you need to worry about a lot of different things. You still have packets and you still have frames, so that part of Ethernet lives forever.
Yeah, I say I think it's so exciting because really, very appropriately and very successfully, we've been on this track for, I don't know, 15 plus years for internet-style networking in terms of networking in the whole. And with Ethernet being ubiquitous, we really open up the design space for solutions at a cost that makes sense, and it really means, wow, we can really rationally think about deploying whole new applications that we might have only been able to glimpse at, when Ethernet ruined my ATM network. That's one way to think about it, only because it was so cheap and available. So some of those design spaces in networking are really opening up to us in a fundamental way. I think that's very exciting.
Yes, Faraj.
Yeah, somebody said earlier that the statistics are that there's now more Ethernet equipment sold than all the other Sonnet, SDH, all of the other ones combined. That fundamentally, from a network perspective, creates a problem when you're talking about a software-defined network or a network that has a different control plane from data plane, whereas everything today, it's got them all bundled up, right? So where the value comes in these types of networks is when you're building large networks, not a little one. If you're building a large network, by definition, you're going to have some legacy type products involved in there. So, the way I see, and again, I'm not a software guy by training at all. I'm more of a hardware guy. But everything that we're talking about has to take place in the context of an evolutionary plan, and one that takes into account the limitations of the existing system and the existing silicon and the existing, hardware that's out there. It's not going to turn over into a,
Well, it sounds as if there's consensus on the panel that this is not an either-or question, that although there's a software model, although there are new content-centric models, say that 3 times fast, that actually may end up selling more hardware, not less, in the long run. Would you agree?
Absolutely. I mean, the key challenge is going to be wire speed and wireless speeds are increasing. So there's always been a push to do any network processing at wire speed. So in the future, if you start talking about higher level functions, content lookup, caching, error recovery, security, how are we going to do those at wire speeds? Part of that is going to be a question of where does computing technology go, but part of it's going to be about the layers and the architecture.
Absolutely. Just to interject on that, I'm a performance test guy, and I remember many years ago when Mick Seaman was CTO of 3Com, and he had this saying that performance goes away as an issue when it's wire rate, period. And
I think there was
the
actually
software, that's going to be an interesting challenge.
Yeah, I think I do want to come back. I think there's a very important point that you just raised, right? And I think it's a very valid one, right? Which is, all of this has to work at scale, right? This is not about taking 10 ports, 20 ports, 100 ports, right? This is about taking tens of thousands of ports
billions
and making
billions.
What's that?
Billions and billions.
Billions and billions, right?
Global
And making it work. And I just feel, right, when you start looking at a controller-oriented model, right? I think there are tremendous advantages to that, but we've got to be also a little bit forward-thinking in terms of what would it take to troubleshoot that kind of a network, right? Because if you don't have that, if you don't design that into your network, you're going to run into challenges, right? So as you think about that paradigm shift, as you think about a software-oriented network, a centralized controller-oriented model, you've got to start thinking about what kind of instrumentation do I need for that? How am I going to troubleshoot that? How do I tap into that network and extract the relevant data? Imagine the controller programs certain things in the switches, and it thinks the switches have those flow entries, but the switches are doing something else. How do you troubleshoot that, right? At tens of thousands of ports, right? And I think bringing visibility into all of this is going to be very critical.
So, sorry, unfortunately, I've got the time monkey on my back. I wish we could discuss this for about 3 more hours, how we're going to implement all these different things, but it's time now to turn to questions from the audience, if there are any. See hands going up here?
It's Bob Emerson again. When I first heard about software-defined networking from Dan Pitt, he was describing commodity boxes like you've just put on the table there, and the IT guys, it's so simple, they can set the whole thing up themselves, and it's the end of the big Cisco switches and the Junipers and all the rest of it. He didn't actually say that. And then later on, it seemed that it wasn't the end of the big switches and the big routers and so on. But what strikes me, Stu, is that if you've got a sort of an SMB, which is global, and they are, lots of them, that they could use these little red boxes and configure the whole thing themselves, and the only service they need to buy is a connection between the boxes. Does that make sense?
I think that makes sense. I mean, I think your question is, how does it impact the market and the bigger box vendors? Was that your? Oh, okay. Mm-hmm. So maybe I didn't understand your question. Sorry.
Sorry. The real question is, sorry about that preamble. Is could an SMB who's international, got offices around the world, just get these red boxes and configure them themselves? It's easy. It's in software. And all they need between the boxes is straight connectivity. They don't need any real service from a service provider.
Yeah, I think if you have a programmable, a remotely programmable standard interface like OpenFlow, absolutely. That really changes the economics. So now, you say, look, if you're going to sell the hardware, you're in a low margin, high volume business like the server business. And if you're going to sell the software, it means your software can run on any of the hardware. So you're really in the software business. So I think that your use case is absolutely a potential with a standard like OpenFlow and with the ubiquitous nature of Ethernet and the falling prices in compute and switching. So, not only is it possible, I think it's inevitable for that kind of model to happen.
I just want to jump in. I think there is a really important role for the software there. I don't think SMBs are going to be writing their own software to control OpenFlow switches, right? There's got to be a layer above that that's going to be written by companies that provide that level of abstraction.
I think it's a huge. I don't want to miss this point. I think the most exciting thing about software-defined networking and emergence of a standard like OpenFlow is that exactly right. The SMBs aren't going to write their own code. They're going to buy the software from somebody, which means for the first time in history, there's an independent software market in networking. That doesn't exist today. So now you're going to see, software-savvy kids coming out of college with white boxes and applications that we can't even imagine in this room, filling a market need that we might not have even good visibility today, but may be just around the corner. So we're in that exciting chicken and egg phase that we, many experienced in the emergence of PC and client server as it moved away from a hardware-centric mainframe and mini computer market.
So we've got time to slip in one more quick question. I think there's a hand here. Yes, sir.
Hello. Sean Hackett from 451 Research. This is a very interesting panel. I thought one of the most interesting thing was I thought I heard, and correct me if I'm wrong, VMware talk about resiliency of the hardware. You've made a business out of abstracting hardware, right? I mean, it's because of VMware and others that we've moved, I think, to this world of, sort of the software resilient data center, right? I mean, Microsoft just built a huge facility, almost $1 billion with no generators, right? Because the software and because of VM mobility, I can just, move VMs around and all of a sudden I abstract the hardware. This has huge implications for the network, and I'm shocked no one's really talked about it. I mean, it's no longer, network traffic going up to a top of rack switch and out, it's east-west traffic, right? what does that do to I know there's a number of questions here, but what does that do to spanning tree? What about trill? What about, so I'd be interested to hear what your take is on all that.
How much time do you have?
Yeah.
I know. Well,
So since you mentioned VMware, and I did use the word resiliency, I just want to say clearly what I mean by that. We depend on there being connectivity between the servers, right? I see the functionality of networking software moves into the vSwitches running in the hypervisors. That's how you get scale and performance by putting those complex functions at the edge. That's how you abstract away from the underlying hardware. But you still want the hardware to get the packets between the servers. Any one router or switch perhaps doesn't have to be resilient, but the overall switching fabric of the data center certainly has to be resilient, and that means things like fast failover when a link goes down, whether that's done through fast convergence of your IP routing protocol or some proprietary thing like fabric path or whatever. Somehow the data center fabric has to be resilient, and so but just like we don't depend on any one server to stay up forever, we don't depend on any one box to stay up. We depend on the overall network to stay up. And that's, I do want to make sure that we realize the hardware vendors still have a job to play here because we depend on them.
But just like redundant arrays of disk drives completely changed the storage industry, I think a lot of the responsibility for creating a network that is completely resilient should really happen at the higher levels. Moving from one data center to another, using content-centric light protocols is one way to do it. There's many others. I think a lot of those issues can be moved up because wireless in itself is not a friendly environment for packets either, and yet that works, but it's done above.
So although we're moving into the software sphere, clearly, it seems that we agree that it is yet one more overlay giving us applications that we're thinking about now, applications we haven't thought about yet, and Ethernet is still there as a constant. So I want to thank all of our panelists for a provocative discussion. I wish we could go on all afternoon. Thank you.
Thanks very much. And it's clear that we have yet to invent time compression. Wish we could, because that one should run and run. But we have a little time now. I think we're going to, Fritz, why don't you come down and tell us what's going to happen next? Because I think we're going to do something a little special here.
Hi, everybody. I'm Fritz Nelson with Information Week. I want to start by first apologizing for my voice. I have a vocal cord paralysis like Larry Page. Unfortunately, I don't have his checkbook, but I was hoping it would be better by today. It's actually getting better, and it will get a little better as I talk. But just know, even though it might pain you to hear me, it doesn't pain me at all. And in fact, the doctor has encouraged me to talk more. So you get to be my therapy. So we're going to do a kind of a unique twist on a panel. Mark has described this as I'm supposed to play the Jay Leno role here. At first I thought that meant I had to write a monologue, which I did, but the censors scratched it all out. So you're not going to get the monologue today. But we're going to have our panelists come up one by one, and we're going to get a little personal and have a little discussion with each one. They're going to stay up here, and then we're going to talk to all of them in a kind of a free-for-all fashion. So that's how we're going to work it, and I'm going to bring up our first panelist. It's Henry Samueli, who is one of the co-founders and the CTO of Broadcom. And I don't know, I guess I wasn't here earlier this morning. I don't know if we've had any chip vendors yet, but you get to represent that side of it now. Henry runs research and development for Broadcom, and he's also a professor at UCLA, and we'll get into this in a minute. He also owns the Anaheim Ducks. So I don't know, probably a lot of people here are San Jose Shark fans, but I don't think there's any reason to hate the Ducks, right?
No, it's a good rivalry.
Okay, all right. I don't follow hockey that. Why are you sitting so far away from me? Is that
my name is here.
Your name? Okay. All
You want me to sit
I
close?
thought you, yeah.
All right.
You can move back down there. We know who you are. Okay. So I want to start out with, Broadcom, you have a pretty good share of the Ethernet market. Describe what you would say your market share is.
Well, I think it's an exciting business. We entered the market roughly in the fast Ethernet generation in the early to mid '90s, and have been proponents of Ethernet for a long, long time, fighting the standards battles, et cetera. Big believers because of everything that you've heard earlier in the day about how Ethernet being an open standard, being scalable, flexible, can adapt to new markets. Like, for example, one that I'm sure Bob never thought about when he invented Ethernet, the automobile. Did you think you'd have Ethernet in your car? But it's happening. So, so when you look at all the different areas where Ethernet is deployed, it just everywhere. And that's been our mantra over the years, is just we drive Ethernet technologies and also wireless technologies, which are Ethernet-like, into every market segment that we see can use that data traffic and data communication. So I'm a big believer in Ethernet and Ethernet-like technologies.
Now, Broadcom has been described as a provider of merchant silicon. And when I first heard that term, it felt a little derogatory to me. Is that, how do you take it?
I've gotten used to it over the years, but when you think of a merchant, you think of like a little hamburger cart off to the side where you go buy a hot dog. We don't quite sell our chips that way, but everybody gets used to that term merchant silicon. But it basically means open market silicon as opposed to proprietary ASICs. And clearly, in the semiconductor business, you have to be dealing with open standards to generate the kind of volumes you need to sustain a semiconductor company, and hence that's why Ethernet is so popular among semiconductor companies, because it's an open standard, so you just continue to drive the cost down.
Many, many years ago, I asked John Chambers, the CEO of Cisco, who his biggest competitors were. And John always gives one of those, who's your biggest competitor? And he says, time, or some crap like that. But so back in those days, he said, point products. He was doing battle with Extreme and Foundry. And then later, he said, somebody that's going to come out of China, by which he meant Huawei and companies like that. And recently, he said merchant silicon. So are you competing with Cisco? Or are your customers?
No, of course, they're a great customer. Anybody from Cisco, we love you. No, you're right. Merchant silicon you sell to the world. Anybody who wants to buy semiconductor chips from a merchant silicon vendor can buy them, and therefore they can build competitive products to any company out there, Cisco included. So in an abstract way, yes, you could say that every OEM views semiconductor companies as their competitor because they're selling chips to their competitors, but that's what merchant silicon companies do.
Now, on the panel previously, we heard a lot about software-defined networks. And what is your view on the role of software-defined networks and the role your company plays? Does it change anything for you?
No, not really. It's just another avenue for the deployment of Ethernet and Ethernet-like technologies. And I think it'll play a very important role in the future. It'll evolve over time, and what we call SDN today may be different than what SDN is in 5 or 10 years. But it's the concept of opening up the standards for software. I liken it kind of to what happened in the cell phone space with Android, where historically all the operating systems and software stacks were proprietary in cell phones, and then all of a sudden Google opens up and gives away for free the operating system, and look what industry it created. So having open software interfaces is an interesting avenue to take in the networking world, and we're fully supportive of it, and in our silicon, we work very close with people developing SDN as well as people developing proprietary standards as well.
Well, let me ask the question in a different way, and we've got a couple of your customers coming up here shortly. Some might think that for some of your customers, the notion of software-defined networks is going to threaten their business. Do you see it that way?
It can. I guess it depends how you look at it. If you can leverage it to make, even if you're an OEM selling proprietary OSs today, you can leverage SDN into creating new lines of business for your company. So I don't view it necessarily as bad for an OEM that has proprietary solutions, as long as they look at it with an open mind and maybe develop products along those lines as well, much like, again, as I said, in the cell phone space, people who had proprietary OSs adopted Android and they're doing quite well. So it can work both ways for you.
Let's switch to a little more chip-centric question. Earlier this year, Intel at the Open Compute Summit was showing engineering samples of 100 gig silicon photonics. What role do you see that technology playing in our switches, and when?
Sure. Well, silicon photonics definitely will play an important role in the future. I mean, if you look at high bandwidth links, 100 gig and above, I mean, they're all over optical fiber today anyway. The issue is, where's the interface to that optical fiber? Today you have an electrical interface at the switch chip that goes through a backplane or some short copper distance, and then it's converted in some optical module to send over an optical fiber. So clearly you can save a lot of power if you move that optical interface closer and closer to the chip, and hence that's where silicon photonics comes to play. And ultimately, if you can put that put that interface to optics right at the edge of the silicon, then you have the optimal solution from a power dissipation and density perspective. So clearly, in the 100 gig and beyond generations, you'll see lots of applications for silicon photonics technology. So it's a good opportunity.
When?
It's starting today. People are working on it today. You mentioned the Intel announcement. There are many startup companies working on it. We're partnering with many of those companies to look at various opportunities. So it's starting today, but when will it be mass deployed? Certainly within the next several years.
And you said you're partnering with companies. Would we see a silicon photonics coming from a company like Broadcom?
Potentially, yes.
Okay.
Anything can happen in the future.
No. All right. I was trying to see if I saw where Rick Merritt was. He's trying to make news. Now, there he is down there. Okay. So we talk about speeds. We're going to have Arista up here in just a little bit. Sick amounts of bandwidth on their newest switch. Lots of high port densities. When will it end? Are we going to reach a point of, we're done?
No, it's a great question, because we're so spoiled over the last 50 years, literally our lifetimes practically. We've been spoiled by Moore's Law, where chips got twice as fast or twice as dense every 2 years. And it was just never-ending exponential growth, and that translated into faster speeds on networking links. It translated into higher density on switch ports and the networking boxes. So we automatically expect it to happen every 2 years, but it's not. I mean, Moore's Law is coming to an end. I mean, people have been talking about it for many years now. The question is when. There's common consensus out there, by the end of the next decade, it will pretty much come to an end. So another 15 years or so of Moore's Law, and then we've got a problem. It's going to take some radical new invention, because standard CMOS silicon transistors will stop scaling once you get to the so-called roughly around 5 nanometer realm. And what that means is that everything's going to start plateauing, that the speeds of networks are going to start plateauing. Now, at what number? I mean, I'm pretty comfortable we'll get to terabit speeds. We're at 100 gigabit today, researching 400 gig, so I can see a path to terabit speeds. I'm not sure I see a path to petabit speeds. So we may be limited at the terabit range. And then you're going to see densities of switch ports start leveling off. Now, every 2 years, you're doubling the density of switch ports in a silicon chip. That's going to start leveling off. So when you start seeing the network level off in inherent capability, it's going to change the dynamics of the entire industry, because you no longer have these exponential increases every year. Now, We still have another 15 years or so to enjoy, but we need to start preparing at some point for a network that doesn't grow exponentially every 2 years.
Okay, I'm going to put you on a spot here. Who's your favorite customer?
You know I'm not going to answer that one.
I thought I would warm you up. And
we
then,
love all of our customers.
Okay, all right. Get a couple more drinks in you and we'll see.
Yeah.
So just to get a little personal for a second, on a couple different fronts. So I didn't know you own, but we're practically neighbors in Southern California. I didn't know you owned the Ducks. When did you buy them?
In 2005.
Okay. And then 2 years later, they won the championship.
2 years later, we won the Stanley Cup. Yep.
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 Yep. And so you're a big hockey fan?
I've grown to become an enormous hockey fan. Yeah.
Were you before?
I didn't start that way. I grew up in Los Angeles, so I was a big UCLA Bruins basketball fan, Lakers fan, and all that, but now completely switched over to hockey.
So why hockey? Why not bring a football team to Los Angeles?
People have tried and failed. I know someday it might happen, but we tried to get a basketball team down there in Orange County. That failed too. So,
one other thing, and I don't know if you're involved in this or not. I actually was in your office, so I think you might be. But back in the day, there was a lot. When I went into Broadcom, there were lots of sports cars, Ferraris and stuff in the parking lot.
The good old days of the internet boom.
Right. Well, I saw a Tesla there last week.
Yep.
So, are you into racing?
No.
No.
Not personally.
Okay.
But a lot of our employees are, actually.
Okay. All right, great. So I'm trying to see if is there something about speed?
I limit the speed to the silicon chips, not to automobiles.
All right. Well, Henry, thank you. We're gonna keep you. You can move back to your seat now. We're gonna put our next guest, and we'll come back to you. So thank you, Henry. Very good. Our next guest is Bethany Mayor. She is the Senior Vice President and General Manager of the Networking Division of Hewlett-Packard. Before joining HP, Bethany was at Blue Coat, Mirapoint, JDSU, and I found out also you have roots back to Cisco as well. So a long and storied history. Now I want to start. I'll let you get settled here, and are you gonna? Yeah, you're gonna be in the right.
Lonely because Henry's way over there. So, anyway.
You just talk to me. Ignore him for now. Now, one thing I want to note about HP, specifically the networking division. I don't know if you know this. 13 consecutive quarters of revenue growth. Now, I did a little homework today.
Actually, 14 as of today.
You're stealing my thunder, and I'm stealing yours, because today HP announced their earnings, and a little bit of kind of bad news. The earnings were down, up versus expectations, so I'll say that. But in almost every area, down year over year. The networking division, up. Wow. So congratulations. 14 consecutive quarters. Now, the reason I'm bringing this up is because I want to know how, amid all the turmoil of Mark Hurd leaving and board dysfunction, I don't know how else to put it, Ray Lane stepping down as the chairman of the board, somehow the networking division just keeps chugging away. How have you done it?
So I've been with HP now for 3 years, and when I first started, Mark Hurd was in place, and so I have seen a lot of changes over the last 3 years, and I thought startups were sort of wild. I've been very fortunate that first, the networking business at HP is considered very strategic. As you know, we made an acquisition of 3Com, my favorite company, 3 years ago, actually. And so the reason for that was because HP really wanted to create this converged infrastructure that we talk a lot about of server storage and networking. So very strategic part of that is the networking part of it. As well, I would say that my boss, Dave Donatelli, is a pretty straightforward business guy. And so he really works hard to keep us focused on our goals. And then the last piece I would tell you is that I think we make great products, very innovative products. We have embraced, as you know, OpenFlow for many years, and frankly, people buy good products. So I think some of it is, frankly, we just have great products that sell.
Well, I have my own theory, which is that even though we're here talking about technologies like Ethernet, so it seems like the topic of the day, I think when people think about HP and certainly the turmoil the company has endured, hopefully behind them now, that they don't think about networking quite as much, for better or worse. But I think it's kind of allowed you and your team to just kind of do their job. Speaking of which, and you mentioned 3Com, talk about where you are now with the merging of 3Com and the ProCurve stuff. Where is that?
So, sure. So we acquired 3Com, and it closed as of April 2010. And so we spent about 2 years actually doing integration between the 3Com products and the ProCurve products that HP has been building now for 25 years. And essentially, the integration of that product portfolio is now behind us. I would tell you, though, that we've, throughout that time, continued to do quite a bit of innovating and bringing out new products every single year. So, it's a testament to both the 3Com folks that we acquired, as well as HP, and frankly, HP has just solid engineering capabilities to really both integrate and innovate simultaneously.
I thought for a while, because you guys bought 3PAR and then 3Com, you were going after all the threes.
Yeah,
Maybe
we like threes, we do.
Okay.
We're fans of three.
Now, HP has been a big proponent of software-defined networks from the very beginning. Can you talk about why that is, and what is HP's stance on SDN?
Sure. Well, HP as a company is a very standards-based and standards-oriented company in all that we do. I mean, really, if you look across the business units, we're very standards-oriented. And OpenFlow was, as a result of a few folks, PhD students actually at Stanford several years ago, who worked on something they called ethane. And essentially, this is Rob McEwen particularly that worked on this. Our HP Labs has been very involved with Stanford for many years, and so they began to work with him on this and eventually moved itself into HP Networking, or at the time ProCurve's labs themselves, to then deploy a commercially available OpenFlow switch. And we did that in 2008. So we were the first company that developed and deployed commercially available OpenFlow. And we've been continuing to progress with that over the course of the last several years, so that now 40 of our switching platforms are OpenFlow enabled, and we have 20 million OpenFlow enabled ports out in the market today.
Doesn't OpenFlow, the sort of notion that we're going to make the hardware part a bit of a commodity, doesn't that threaten HP's networking business?
So one of the panelists just a little bit ago mentioned that it depends on how you look at it. From our perspective, we've actually embraced SDN. Frankly, we have a lot of capabilities in our software and in the functionality of the software that we bring to the market, even currently in the management platform that we've developed over the last several years. But we've now built our own SDN controller, and we've also created APIs that are open for folks to build applications on, and then we're building applications on them. And from our perspective, our focus is around simplification of the network. And it's also based on convergence of technologies in an intelligent way to give our customers value. And what SDN brings is the ability to, be able to abstract a lot of the difficulties that have been frustrating to the network administrators and to IT in terms of just having to go box by box by box using Perl scripts in the CLI to make changes, right? So this allows customers to have a much more flexible way of changing their network, and they need it for what's coming, which is, you know, a lot of big data and cloud, et cetera. We feel very strongly that customers pay for value, period. So whether it's in our ASICs that we develop, whether it's, and we utilize for special purpose, whether it's our SDN controller or whether it's application, there's value there, and customers will pay for that, and we're very comfortable with that as a company.
So you recently announced your Flex Fabric, which I challenge you to say 3 times fast.
Yeah, my marketing guy is maybe here. Flex Fabric, Flex Fabric, Flex Fabric.
All right,
that's the fast I can go. So.
But in the announcement, it was called the first chassis-based switch to support OpenFlow 1.3. There's not a lot of OpenFlow implementation happening, at least on the enterprise side, and I don't know on the carrier side that much. But why is it so important to be the first?
Well, we really feel that there is going to be a huge sea change as a result of software-defined networks and as a result of software control in the network itself. And so a number of things. One was we actually do have customers who utilize OpenFlow today and have been utilizing our OpenFlow interfaces for many years, primarily in the research community. And then what we decided was, you know, as the emergence of OpenFlow as a true standard and our ability to create a controller, we then are able to provide something that's very enterprise ready and hardened for our commercial customers. So that's why we went to building at the controller itself, right? Because we believe that customers really are looking for a big change in their network. It's a very difficult thing to maintain your network. It's an even more difficult thing to change it in any way, to reconfigure it. And the amount of errors that go on as a result of changing your network today is quite high. So by putting in place more software-oriented ways to control your network, we believe that that's very valuable to our customers and compelling, and that the industry will embrace it. And I have to tell you, every single customer that we talk to is very interested and wants to do something utilizing software-defined networking.
And what are your thoughts regarding what Henry and I talked about with Silicon Photonics? Mm-hmm. Does HP see a future there? And you know, I'll ask you to respond to the sort of plateauing of speed on the network.
Sure. So yes, HP has been very involved with photonics research. I mean, HP, you know, is an iconic company, and I'm actually very thankful to be there because this is a company that does research, real research, versus sort of, you know, generally just acquiring a bunch of different things and integrating them. And the research that we did was primarily around photonics in HP network, in HP's research team, as well as in the networking business. And we believe very strongly that photonics is going to be very important as we near the 100 gigabit mark in terms of speed in the network. And it will really, I think, change, and this is the CTO of our company, Martin Fink, has talked about this, really change how the data center is structured, how it will look, even to the point of, you know, where chipsets, CPU processing versus memory is. I mean, there's so many things you can do as a result of utilizing photonics. And so, anyways, we've been very involved with it, and we are right on top of this trend as well.
Now, Henry owns a hockey team.
Yes, he does.
The guy who's coming up next, I think, is like a yacht racer or something. What do you do for fun? I mean,
I work a
top
lot.
that.
So I work a lot. I watch hockey. I love hockey. Actually, my husband's Canadian, so I know more than you might think about hockey. And my husband and we have a granddaughter, so we're kind of involved with our family, and we spend a lot of time with our kids. So
Who needs hockey? Okay, great. Thank you so much, Bethany.
you're welcome.
Our next guest is Andy Bechtolsheim, who is the founder and chief development officer for Arista. Now, before Andy was with Arista, he was the founder and chief system architect at Sun, and before that with Granite as well. Hello. Good to see you again. You know, we didn't have a chance to debrief, so I'm going to take a little leeway here with you and put you on the spot as well. And this is regarding your previous role as the chief architect at Sun. What do you think of what Oracle is doing with?
Recently, I have no clue. But I was going to comment, you know, Sun started because of this vision that the network is the computer and every product sold from day one had an Ethernet interface. So we were one of the earliest adopters of Ethernet. In fact, my involvement in Ethernet dates back to my student days. I came to the States in 1976, and I was at Carnegie Mellon University back east, and my advisor was Sam Fuller, who later was at Digital Equipment. But he did visit Xerox PARC, and he came back one day and he said, I have seen the future. It's called Ethernet. I said, you know, what's Ethernet? And he goes, it's this yellow cable that just connects all these computers there. Well, I was very impressed.
Well, I will tell you that Oracle and its competitor SAP are building these basically in-memory database products and selling these purpose-built application boxes, so to speak, Exadata, SAP's HANA, and they're kind of taking those Sun server systems and making them more task-specific, application-specific. And it seems to me that in some ways there was a vision there at Sun for that too.
Well, I guess I can comment this a little bit, which is, it is true that delivering a high-quality hardware-software solution of a cluster-based, scalable enterprise Exadata, whatever it is a hard problem. So there's a benefit to both the vendor and the customer to have these sort of vertical appliances, if you will, that are fully qualified, fully tested, and they come out. Now, it is a thing that is sold for the value of the software more than the hardware, I would guess. But the point is, it is unique in the sense that other people have not unique. Other people are now following this. Like I hear IBM is now positioning their PureFlex system to be this more integrated hardware-software approach, and it actually does make sense because in the end you buy hardware to run software.
So you are paying attention to what they're doing.
Well, it's good for applications where people buy into a very reliable, robust software stack, and they want to have the utmost in quality and reliability. So that's sort of the position of this. Now, the alternative view is what's happening in the cloud, where people buy, motherboards made in China, and then develop their own software stacks based on open standards to compete with this. So there is an emerging trend in the cloud that is actually the same idea, but based on open standards.
Well, there's a reason I'm bringing this up, because in some ways, companies like HP and Cisco on the networking side are trying to build that stack, especially around SDN. Now, if I may, and I have to look at my notes here because these numbers are mind-boggling.
Can I pitch in here? So SDN is a completely different vector here, right? In other words, the vertical stacks that seem to succeed in the market have APIs and software on top of the API. And the same cannot be said about networking, at least today. It's just not the same, and there's no application software that runs on top of the SDN world today.
There was a guy here from Infoblox, Stu, was saying that they have something. So we're getting
and there's early examples. For example, it was publicly announced that we recently partnered with SAP HANA to provide a network switch for their HANA cloud appliance, I guess it's called. And the reason was that they could integrate their system management with our network transparently in a matter of a week or two of effort, which they couldn't do with any other vendor, apparently. But it is true that these things are getting integrated because what the customer wanted was one system to administer, certainly.
Right. And so this latest product that you guys had won a Best of Interop award, the 7500E, 30 terabit per second backplane, mixtures of 10, 40, and 100 gigabit ports, lots and lots of ports depending on which of those you pick, right? And very low latency, huge buffers, big time scalability, low cost per port. You guys have built really a pretty incredible sounding box, but is it just about the speed? The monster switch, I like that. Is it really just about the speed?
No, let me go back to the beginning of Arista, which is when we started, we thought the problem was actually software, not the hardware. You know, we saw the emergence of merchant silicon, and in fact, the 7500 uses silicon from the gentleman on my right here. And so the silicon is getting more and more expensive to do. It's really not economical for anybody except, you know, the one company that has the dominating market share to build their own chips. And furthermore, the merchant chips, at least the ones we're getting, are actually better than the kind of chips other people are designing internally. As a result, there's really no reason for anybody to make their own chips these days. But the problem is the software. So we have this saying internally that hardware is easy, software is hard, which is really true. You know, in networking, you have a software stack that's, let's just say, 5 million lines of code. And the problem is, if one line is broken, the whole thing crashes, and you know you cannot sell the box to anybody who cares about reliability, which is your entire customer base. So we managed to break this software up into these tiny little modules that, you know, separate Linux processes. It's all reliable, has an internal memory database, and it actually works as advertised, meaning it's exceedingly robust, and at least our customer tells us it's more robust than the competition. What this means is that, you know, people only buy into big switches if they don't go down, and the barrier to entry is actually not the hardware, but actually the software.
So just to prove to you that I read some of your literature, I wrote down some terms: universal network architecture, build it once, get the network out of the way. What does all that mean?
No, that's okay. What we call the universal network is really the conclusion that when people have cheap enough bandwidth so they can build a completely non-blocking network with, you know, not just thousands or 10,000s, but 100,000 servers in the cloud, where you no longer have to silo these things into zones or containers or pods or whatever they call them, the customer is actually much better off because they no longer have to worry about data placement and compute placement. The problem before was they had these sort of smaller zones, and then when you run out of the capacity in that zone, what do you do? Because you're connected to the other part of the next zone, but it's a low bandwidth connection. So a universal network is one where you no longer have to worry about the network. I mean, the whole argument here is that the network really should be invisible to the applications. It's like if you don't see it, that's what you want, right? You get the same latency, the same bandwidth, the same throughput wherever you are. You can, you know, communicate from server A to server Z. It doesn't matter if the same rack, the next rack, or a building across the campus there. And that is what people are designing. And the advantage of that is you no longer have to worry about designing a network around the application. It works for any application. It doesn't matter whether it's a Hadoop thing, a search engine, a game engine, or, you know, storage cluster or whatever it is. It all works with the same network, which is an incredible simplification for customers.
Okay, I do want to come back to SDN. I'm going to read 2 quotes from Jay Shri, your CEO. SDN is not about replacing existing network architectures and topologies. And she also said, Arista does not believe in a rigid separation of control plane from data plane. So what is Arista's approach and stance towards SDN?
So there is a lot of interest in SDN for all kinds of use cases, including just OpEx cost reduction, you know, making things more manageable, reducing, you know, the number of network engineers running around, and so on. Now, our view has been that, you know, this is an incremental deployment kind of scenario, not a greenfield scenario. In other words, people are not waiting for SDN magic to show up to design the network around SDN. They want SDN on top of an existing physical network, and it has to work with both the virtual switches and the physical switches and so on. So arguably, we actually have the most programmable network stack out there, and we today support any type of open daylight, big switch, open flow controller, in the sense that it was really easy for us to add these kind of support things for different customers. But what we are finding is that it's really driven by use cases where people can see a clear benefit of what they want to do with this, and we can enable this at both the virtual switch, physical switch level, and then tying this back into a virtual switch management system.
Now I've asked Henry and Bethany about silicon photonics, and you were there when Intel announced that and were showing.
Yes, I'm a fan. Yeah.
Do you have some with you?
Well, I usually carry some in my pocket, but not today.
Not today.
Now, the point is that if you look at the cost structure of high-speed networking, meaning 10 gigabit and above, it's actually, sadly, dominated by the optics, not by the silicon. I mean, this is kind of a shocker, but the optics cost much more per port than the silicon. And that inhibits the market, in particular when you get to the 100 gig level. I was just sitting next to Tam DeLauro, and she has this beautiful Ethernet forecast report, and even the report, the analyst basically says they cannot forecast the 100 gig market because the optics are so expensive that nobody can afford it. So the difference between optics that would be priced correctly to the market where they have to be versus the situation today is a difference of 100 to 1 in volume for 100 gigabit. And basically 100 gigabit won't take off at the current price points because it's just stratospherically priced. So our customers tell us that they won't deploy 100 gigabit until it costs less than 10 times 10 gig. It's that simple.
And I'm under the understanding that your technology is being deployed in a lot of the financial services sector, where speed, especially for things like algorithmic trading, is essential. Is that true?
Well, at the beginning of the company, that was the majority of business was high-frequency trading, otherwise known as legalized front-running. And until today,
we just call it capitalism.
We believe that the majority of stock trades actually go over Arista switches, but that was years ago. Okay, today the majority of our business is actually cloud networking, meaning large, large-scale data centers that do the cloud stuff. And we've been very fortunate to have a product line that fits the requirements of those customers and has scaled to 100,000 servers and beyond.
And because I asked Henry and Bethany, so what do you do in your free time? What's your hobby?
Oh, in my free time, I worry about networking.
What's your hobby? None of these people have free time.
No, I work 8 hours a week, so I don't have a lot of free time.
So you're a workaholic.
Well, I don't work for a living. I work because I enjoy it. But the point is, there's a lot of innovation and opportunity here, and Moore's law, at least for the near term, has no signs of slowing down. So, I actually would phrase it. I know long term the prediction is a little more difficult, but short term, we actually finally back on the Moore's law curve, where the last, let's just say, 10, 12 years. We're really quite slow, where the market leader didn't have a lot of incentive to essentially improve their product very quickly. Whereas now with the advent of merchant silicon, every other year there's a chip coming out that's twice as good than the previous chip. So this is unheard of in recent history in networking, and it really allows networking to keep up and to catch up with the demands on the server computing side, because obviously, faster Intel servers need faster networks to deliver faster results. So all of these things go hand in hand, but there was a risk at one point that the network just wouldn't keep up. Meaning, if you think about it, it took 10 years, from 2000, let's just say 2000 till 2012, to go for Ethernet to go from 1 gig to 10 gig in any kind of volume, right? Now it's going to take just another 2 years until 40 gig may be actually the highest volume thing in a data center, and then a couple of years later it's going to be 100 gig. So we're seeing a very nice, much shortened upgrade cycle that really helps customers to deliver much more bandwidth to the applications than the last 12 years. And I wanted to thank you to the gentleman on my right here, especially.
He did say you were his favorite customer. I mean, he also said,
wait a minute, that can't be right.
Let me say one more thing. Meaning, the thing about silicon is it really is getting more expensive every turn. A 28 nanometer chip costs twice as much to do than a 40 nanometer, and so on. And the only worry I would have, in this whole business is if that it gets so expensive to make a new chip that people couldn't afford it anymore, that would be a problem, okay? But so far, there's no signs of that. So far, there's enough market size and the market is growing and people get a return on the investment, they can keep justifying making those investments. And that's true, for the chip vendors as well as at the system level.
So I'm going to move you down to your chair at the end. Thank you very much. Great job. Now I'm going to bring up Dave House. Now, when Dave came to us as a last-minute addition to this panel, I was like, Dave House. I have not heard that name for a while. And then come to find out that Dave is the chairman of Brocade. So I guess maybe I'm out of the loop or something like that, but a few other people didn't know that either. But if you do remember Dave, he was the CEO of Bay Networks, which was the company that formed when Synoptics and Wellfleet merged, right? And then that got bought by Nortel, and then I think you took a little vacation, and then they imploded, or at least that's my version of the story.
I spent a year there, and then I left, and then they imploded.
And then exactly. You should have stayed. But thank you for joining us. And
doesn't Jay Leno usually sit down?
I know.
You need a desk.
Mark, why don't I have like a chair, a comfortable chair? I'm getting tired standing up here, too. So I guess one of the things that I was trying to remember, and we were talking before, somebody mentioned Proteon, and so, the Bay comes up. And what were you guys relative to Cisco in terms of size? I remember it being a pretty fierce head-to-head battle back in those days.
Boy, we're back to history again. We started with history this morning, now we're back to history again.
That's right. That's what we're here.
So Cisco was certainly larger, significantly larger than Bay. Bay became, I think, the big competitor, clearly, to Cisco in those days, and that's probably why we were popular to Nortel.
Right. So fast forwarding to now, you're with Brocade. Tell us about your journey there and what they're up to.
Well, Brocade's an interesting company, an interesting situation. They're a data center company. They make storage area networks using fiber channel, and that's 70% of the business, and they've got about 70% of that marketplace. But there's a huge transition taking place now with the cloud, with big data. Big data was always there. It just happened to be in the big banks and the big manufacturing companies, and it was inside a big data center, which, of course, had redundancy and backup in other physical locations and data lifecycle management and all that sort of thing. But it existed in a different kind of format. Today, we're finding big data everywhere, in the data center everywhere, and the same kind of problems that existed in the classic data center. That is, the data center was created when people observed that mainframes were going to go away, and mainframes attached a bunch of spindles on one side and several mainframes on another, and we needed to attach servers to spindles. And guess what? That's east-west traffic, and that's where fabric was invented. And low latency time, high availability, easy configurability, self-configuring, just plug in a box and it self-configures. Those are the things that were needed at that time in the 90s when fiber channel and Brocade was created. Today, we're taking that to the Ethernet world because the future is about Ethernet, and that is the dominant technology, and that's what's increasingly in the data center, but doing it using the things that we learned in the fiber channel space. And so very low latency, totally east-west traffic, nothing hierarchical, easy to manage, easy to configure. Self-configuring, add more capacity, just add more boxes and they self-configure. Reroute relative to failure, ability to handle redundancy, ability to handle redundancy between physical locations, your ability to keep your big data in multiple locations, and of course, it's all about east-west traffic, low latency times.
And Brocade acquired Foundry on the networking side. How did that go? I mean, I haven't heard much about Foundry, which could actually mean it went really well. It was digested and, we just don't know it.
Well, Foundry was a great acquisition because it was producing very high performance products and a limited set of customers, but some very important customers in the federal government space and all the three-letter acronym black agencies, in carriers in terms of content delivery networks and very fast bandwidth dedicated kind of networks. But because it had performance, it provided a great level of expertise in the Ethernet space that we could take with our fiber channel space to create Ethernet fiber. And so the focus today is on Ethernet fiber, the ability to handle these big data centers and big amounts of east-west traffic.
Now, I asked Bethany and Andy about the threat of SDN to their business. How does Brocade look at it?
It's an opportunity for us. We're still a small player in much of that space. We actually look at it as not being that much different than what we've ever done in our business. It is something that needs to be, it's not a simple transition to get there. For one thing, as Andy pointed out, there's a little thing called an installed base out there, and we need to be able to evolve upon that. I spent 23 of my years at Intel, and I learned very much how evolving the microprocessor forward in a compatible fashion, in a smooth fashion that was easy for the customer, is critical, and it's got to be done in that way.
Now, at lunch, we were talking about your own personal endeavors in the wine business. So what got you started there?
Well, at Intel, because I was the one guy that came out of the customer base. I used to design mini computers before Intel. I was a guy, the salesman wanted to talk to customers, so I always was at dinner and I was always handed the wine list and had to choose the wine, and I used to give it to the salesman. After a while I started choosing it myself because I knew what I liked, and so I got interested in wine. I built a house, I had a lot of land, I thought it'd be nice to put a vineyard in, and so I planted a vineyard in '98, and that was fun, and we made our first wine in 2001, and now House Family Winery is making some of the best Cabernet and Chardonnay in the Santa Cruz Mountain AVA.
We're all wondering where our bottles are.
Put House Family Winery into your search engine, you can buy it there.
Okay. Search engine, you say?
Yeah.
Okay. All right, well, you know what, you can stay here.
Oh.
I'm gonna move your,
Okay.
I don't know, we're just gonna keep a gap between those guys.
You can
and
sit down
guys.
now.
Yeah, you could sit if you want.
Is that gonna create a problem with the mics? Can I sit? I'll stand, it's fine. I think I'd rather stand. I get a little antsy if I sit. So we're gonna just open this up as a panel. We're gonna talk a little bit more about SDN, and we're gonna talk about the future of networks, what's gonna drive some of these fast speeds, even less latency, even higher speeds, and kind of the future, some of the things that Bob talked about this morning. But along the way, of course, queue up your questions as well, and we'll leave some time for that at the end. So coming back to SDN, and anybody can jump in and answer this question. Some of the founding members of ONF were Google, Verizon, Facebook, Deutsche Telekom, Yahoo, Microsoft, and these are some of the people who have been the proponents of software-defined networks. The publication that I work for, Information Week, did a survey of its readers asking about SDN deployment, and it was, I think, somewhere around 4%. So my point is, this is kind of, in our world, a first world problem, isn't it? I mean, when will we see SDN being...
Well, this is classic of any technology. I remember when Bob Metcalf used to walk around and saying, next year is the year of the land, and then the next year he'd say, next year is the year of the land, and then it was next year, and then it was last year was the year of the land, because it just had happened, and any of these technologies come up in an S-shaped curve, and we, the technologists, always think they're going to be here before they're here, and then all of a sudden they're there before the incumbents, it's there before the incumbents. knew that it was really important.
I thought that 2001 was going to be the year of video, but that didn't really work out, so it took a little while longer for that.
But it got here.
It did get here, and what I would say, so HP was a founding member of ONF, just to be clear on that one, and we think it's
But you're not a first-tier member, apparently.
We're not a first-tier member.
Oh, did you lose Stan?
We're
You're not
on the,
on
no,
the, yeah, you're not on the.
Okay, fair enough. Even so, we think it's very important, and we do think that it will be it is a big shift, and I think that the industry, unfortunately, has kind of collated around a particular way of networking that I don't think was all that advantageous to the customer. And primarily it was difficult, and only certified people could do it. And when anybody needed to change anything, it was very nerve-wracking because they didn't know if the whole thing was going to come down or not. So I think that the ability to allow it to be easier to change, to be quicker to change, more flexible, is very important, however we get there. And this is a way to get there. That's how we think of it.
Well, I mean, it sounds great, but so few are doing it. So what are, other than, everything takes time, what are the challenges that have to be overcome? Why? I mean, when I talk to IT managers, network managers, there's a fear that it's complicated and change is not good. Is that last one on there?
I'll grab this one. We'll shift to the left here. So even the 4% sounds a little high to me, by the way. It's very, very early stages in SDN. And people can't even agree what it actually means. What are the real use cases? I mean, it started off as OpenFlow, and then it finally dawned on people that OpenFlow is just a device driver, right? It's like, that's just the interface between the controller and the switch. It doesn't do anything else. I think there's an emerging consensus now that more centralized management would be a very good thing. Being able to administer policies across a whole set of switches. Whereas centralized control planes is a real challenge because if that thing goes down, your entire network fails. So the original notion that networks survive because each switch is actually an independent entity, independent of the others, has some real value that actually gets lost if the whole thing becomes one centralized controller. So to deliver a centralized control, no fault, 100% reliable, robust plane hasn't been done. You would have to scale to millions of flows and lots of events, and there isn't a product you can buy today that actually does this. So SDN deployment has been largely in research labs, universities, people at special use cases. Like tap aggregation is an interesting one. Like people want to tap a whole bunch of flows and they don't want to spend more money on what do they call these boxes? The sniffer kind of boxes. So there's interesting use cases, but people are not displacing the networks that have been designed at any rate that I can see.
Right. Now, Bethany, you brought up video. And I think one thing that happened there over time was we started to see, I may be overstating it, but killer apps, video conferencing, video chat. So from your point of view, what's going to be the killer app? Because I think to some degree, a network administrator is going to need to see that compelling value proposition in a killer app.
I think there are a couple of big things. I mean, one is cloud. Cloud is, we have a lot of customers who either want to build their own private cloud or they want to use a public cloud or they want to do both. They want to have hybrid clouds. And to do that, and they're satisfying DevOps folks and they're satisfying their user base because of, SaaS-based applications. And I think that right now what has happened is that the long pole in the tent has been the ability to modify the network to make that possible. And so they all need to have some level of more agility in their network to be able to solve for that. But I think the other thing too is that we'll see a lot more movement of big data going across from server to server and across the enterprise, and I think that will have an impact on how fast you can modify that network and what you do with the network. So those are some applications that are sort of present that people have to worry about that make the network sort of a stumbling block instead of a help to the business. Some applications that we've seen that are interesting to people and that we've actually developed some capabilities around have been security, primarily. Being able to dissolve some of the security requirements into the switching fabric itself, which has never been done before. And we try to do it with, as an example, network access control. What we ended up with was a bunch of boxes sitting next to switches, and that really wasn't helpful. So there are some applications where if you could dissolve that capability, either it's load balancing is a good example, or security into the switching fabric, things can be that's a very helpful thing for the customer.
Now, I want to ask you, and I realize that there's a danger when I bring up an example like Google, that we're talking about an outlier here. But Google is making their own switches using merchant silicon and putting a lot of weight behind the open source routing project. Does that help or hinder other efforts like OpenFlow? Anybody?
If I could comment this. So Google is essentially a special case where they very early identified a need for very scalable networking. I think it was back in 2005. There was actually an RFQ out from Google. It was just one line, which is they wanted a switch with 10,000 ports, gigi, non-blocking for $100 a port. And the product didn't exist and barely exists today. But their conclusion was, they're better off just going off and building their own switches, and they have a fairly good-sized team. I believe it's around 300 people that both designs the software stack they run as well as operate the network, right? Now, Google, of course, has a scale in terms of their infrastructure that's unmatched by any other entity, and nobody else has quite followed them in their footsteps. When people may have Google envy, but what they're finding is it's actually very expensive to build your own networking stack from scratch, because if it breaks, your network is down, and then your website is down. So people do need a network in the cloud that never breaks, and that's a fairly high barrier to entry, whether you do it internally or come in as a vendor. So what we see happening is there's enough competition on the market that the prices that the large cloud people pay for networking are actually quite reasonable, and we don't see anybody else thinking they need to build their own stuff to get it much cheaper. It's a reasonably attractive business proposition to just go with off-the-shelf equipment.
Yeah, it's the market is segmenting is what's happening, right? I mean, for now, and then it might be that folks are going to go more and more to the cloud and just utilize the network in the cloud. But for right now, there's a segmentation between sort of the cloud environment which is kind of hyperscale, and then the rest of the enterprise world. But I do think that the cloud is changing things because folks are going to shift more and more to service providers and to the cloud, and then the question is, okay, then what happens then, right?
I have one more question on this. Earlier today, there was a gentleman from Cisco up here, and he talked about what Cisco is doing with Open Daylight. Now, I thought I saw other panel members roll their eyes. Or maybe it was just me. But, the proclamation was, it's an open standard, developed and encouraged by Cisco, and we would like others to be a part of it. Reactions to whether that helps or hinders software-defined networking. They have a thick skin, so you can say whatever.
It is an open standard, so that is true. And I think there's actually a growing momentum behind this, because there really wasn't a need in the market to have different kind of APIs or other unique differences between vendors. I think that the real question is and remains, is Cisco wanting to make this this is the standard, or there's something else coming that is the enhanced proprietary version of that standard, right? So Cisco is famous for taking open standards and making it so complicated that only they can deliver it. And so I think that's what people are worrying about or wondering about. But open standards are good. Ethernet is an open standard. We all like it that way.
From our perspective, so the Open Daylight Forum, which we actually are a member of, it's an open source controller is what they've been building primarily, and they're looking at other things, but basically that's the focus of it. That's what's been focused on. I personally, our belief is that the northbound APIs and the southbound APIs need to be standard-based. So you need to have a standards-based programmatic interface to the devices in the switching infrastructure to be able to change them, to do things with them. And you need to have APIs that allow people to write applications to that network to then make those changes. So the open source controller is great. I don't know if anybody in the enterprise would really put it in their network. I mean, given, of course, the resiliency concerns that they have even with a controller, much less anything else. So it's interesting, but, you know, again, I think back to Andy's point, what's going to happen next with that and why, you know, what will change with regard to that open source, so to speak.
Okay. Henry, I want to get you back in the mix here, and you mentioned in your early remarks about cars with sensors. So we're talking about, you know, these unbelievably fast speeds, these bigger networks, more capacity. Is it the sensors? Is it the Internet of Everything that's driving this? Is that what's going to consume all this bandwidth in the future?
That's certainly going to contribute to the amount of bandwidth in the future, because if you get literally trillions of sensors, which could happen over the next couple of decades, where everything in the world is going to be sensed and communicated into a network. You'll have a wireless interface on one side and an Ethernet interface on the other side. So that data will just overwhelm networks. So we need to scale up, obviously. So that is one component. But then normal use that we're doing today, as you drive more and more video into the network, more and more high definition content, if YouTube goes to Ultra HD, then bandwidth is just going to get gobbled up. So there are many drivers of bandwidth in the network, but certainly sensors will be one of them over the next couple of decades. Can
I just comment on what Henry said earlier about Moore's Law and sort of the doomsday prediction of 15 years from now? In the 70s at Intel, I started preaching about Moore's Law and about how the semiconductor, that Moore's Law was going to solve all the problems and the next generation was going to be great. And Gordon stopped me and he says, Dave, he says, you know, this is all true, but I think about 10 years out, I don't think we're going to be able to continue this. And 10 years later, when I was still talking about Moore's Law and microprocessors, Gordon said, Dave, I only see about 10 years here. And it became a regular thing at Intel strategic planning meetings that Gordon would give his prediction, and Gordon would say, well, I see about, but beyond 10 years, I just don't see how we're going to get that. And it may be that, and by the way, and all along there were naysayers saying, we're against this barrier, we're against that barrier. And as time went, there was enough money spent and enough smart scientists that we got by that barrier. And it could be that we're going to run into a firm barrier, but I wouldn't count on it. I think the demand is going to be there, and the consequences, financial consequences of us not breaking through would be so severe. There's going to be a real motivation. And so I think what we can say is we got 10 to 15 years visibility, and beyond that, we don't know how we're going to solve those problems yet.
Did you have something you want to add?
So I think the killer app with the demand driver is just cost performance. Basically, the cheaper the network bandwidth gets, the more people buy. And the reason it's just a good investment, it's much easier to essentially over-provision networks to have spare capacity than trying to worry about what happens when you run out of capacity, because then nobody can figure out what to do. So people are buying and putting in much more bandwidth than even we had assumed people would do even a few years ago.
And then they're using it all up.
Happens this way.
So let's, Dave, I know you have some strong opinions about the future and what it holds in regards to healthcare and education. What are we going to see in this instrumented world?
Well, three things. Two very positive and one very scary. We're going to see incredible transformation in healthcare. If you think that the sensors inside your smartphone are amazing, think of what happens when you start applying those sensors throughout your body. If we can put a chip in every dog, why can't we measure the triglyceride and the blood pressure and the doo-dah? Why can't we monitor the activities of every individual? Why can't we use that to better treat people, to lower the cost of healthcare, to improve the quality of healthcare? Education. Education is just about ready to go through a major transformation. Bob talked this morning about MOOCs and the big role that they will play. But the combination of what's happening at Khan Academy with supplying video training, then test comprehension, and then send you a different video depending on your comprehension, so that the smart kids go like this and the average kids go like this, and people who didn't handle the prerequisites go back and relearn the prerequisite before they go through. So directing people through CK12 with textbooks that are nonlinear in their motion. So rock star professors, so the best explainers teach everyone, and the teachers wind up being the mentors. Or maybe it's social networking, it's the other students that help explain. The transformation the network is going to make in technology and education is going to be phenomenal. And Common Core, a new standard that's coming in 2014, which changes the way students are taught, is just enabling this technology transformation. Very active in a number of areas there. Those are two pieces of very good news. Now the bad news. Security is going to get worse. It's terrible now. The government has declared that cybersecurity is our biggest threat. We've got North Korea with ICBMs, and we got Iran developing an atomic bomb, but that's not our biggest problem. Our biggest problem is cybersecurity. People are worried about, well, with all this information out there about me, I'm concerned about my privacy. We'll give it up. It's over. Everybody's going to know everything. Now there's going to be government policy, political policy relative to who has access to that. Right now, Amazon and Google know everything about everything you do, and the ads that pop up are all related to stuff you have been looking at or you thought about. They already know about you. Guess what? Larry Page doesn't give a damn about you or any of that information. It's just a computer out there that knows about you. It's not people out there that are snooping into you. This is just a bunch of data in big data and databases that's marketing to a market of one. That same technology is going to allow us to educate to a student of one. And that information is going to be out there, and everything is going to be known about you. And the guy who can hack into it is going to know everything about you. It's the hacker you need to worry about, not Google itself. The scary part about that is everything we're doing is layering on layers of abstraction. We've been spending the last 40 years abstracting up from the piece of wire to higher and higher levels. And virtualization and software-defined networks are just another layer of abstraction that we're putting into the environment. And every one of these layers is a tunnel that people can go through to access things that they shouldn't have access to. So.
But there's somebody in the middle between Larry Page, who doesn't care about it, and the hacker who does. So a couple weeks ago, I was talking to an architect at Allstate, and I said, with these phones, you could tell whether, potentially, I caused an accident or I didn't cause an accident based on the sensors and accelerometers and whether I was being a safe driver. That could be good for me because it could help me, if I'm a safe driver, I could be telling Allstate every time I drive and move. Or,
black box.
Right. Or the opposite if I'm not or I did. So that's kind of creepy.
Yep, and the more we know about people's health, the more the insurance company, which is basically an economic engine which would like to be able to provide the lowest cost insurance to the people who cost the least and charge a lot to the people who cost the most, will have more. If they have access to that information and they're allowed to price, then insurance is basically, as we know it today, winds up going away. People who need it won't be covered, or there's the social implications of this are phenomenal, and the policy issues on the political side, the government side, just outweigh basically everything else we're talking about. That is going to be the big issue that society is going to have to deal with in the next 10 years.
Right. And by the way, after I told him that, he said, "How did you know we were working on that?" So
the insurance guy.
Yeah. So
I guess my comment would be with regard to what this is going to do. I think connectedness is going to have a very dramatic impact on the increasing the quality of living, quality of life for countries around the world. I think as you get more connectedness, you get more education. And as you gain education in a population, you increase their ability to to develop their country, et cetera. So I think that connectedness over the next several years, and especially with Ethernet continuing to be more ubiquitous in more countries, it's going to have a dramatic impact on the quality of life across the world. So I think that is another big aspect of why networking is so important and what it means.
Questions from the audience? Got one there, one there, one there. Only this half of the room wants to ask a question. Go ahead.
Alan Weisberger, IEEE Communications Society, Santa Clara, California, USA. That's what I was asked to do. Question primarily for HP, but I'd like other panelists to jump in as well. We see a tremendous amount of confusion in what you're referring to software-defined networks or software-controlled networks, which let me simply define as separating the logical network from a physical network. We see the pure SDN with the rigid separation of control and data plane and use of OpenFlow as advocated by the Open Network Foundation and Stanford University. We see an overlay model where essentially you have two control planes. We see company-specific versions of network virtualization like VMware's. And then finally, we see people claiming support of something that doesn't exist, the ETSI network function virtualization specification or standard. And in fact, there will be no standard from that activity. Rather, they'll be inputting contributions to ITU Study Group 13. So the question I have is, with all this confusion, isn't this whole market in danger of market segmentation and churning? Thank you.
So I'll start, and I'm sure my other folks want to talk about this. So yes, there's confusion. I would agree. I think that people are just learning about this and understanding what it might mean for their company and their organization. I think that different companies within the industry have different definitions of SDN. I agree with that as well. But with all things that are big changes, that are sea changes, they're going to shake out. And I think the value of being able to have some more sort of a centralized control mechanism for the network appears to me, as I talk to customers, to be of a compelling nature for them. They really want this. And they're really tired of, hiring lots and lots and lots of people with very specific credentials and paying them a lot of money to hopefully hold up what they consider to be kind of a mess. So you're right, there's going to be confusion. I'm not sure if it'll cause segmentation. I'm hoping, frankly, that with the use of standards that won't come to pass. And so that's why HP embraces those standards so heartily. But, this is valuable to all the customers I speak to. They are very interested and want it to happen. So the question is, we as vendors have to do our best to support, them getting it in a way that is standards-based and open and flexible for them.
So yeah, I would add that centralized management and orchestration, I think, is the number 1 and number 2 and number 3 use case for SDN. Now, funny enough, this has nothing to do with OpenFlow, which faces some, let's just say, technical challenges in terms of size of CAM tables on current silicon chips, which actually make it really hard to implement. So this centralized management aspect is an OpEx reduction, which people desperately want. We haven't seen too many people who wanted to do a, try out something completely unproven in a network and see if that sticks.
Anthony Savas, ComputerWorldUK.com. I mean, for good historical reasons, obviously the US has dominated the way we actually develop networking over the next 40 years. But obviously there are more network engineers coming out of China, India, Korea and Africa every year than anywhere else. I mean, surely the next 40 years of networking standards are going to be decided by those continents rather than over here.
Well, are you talking about the standards or the vendors?
I'm talking about the general markets, because I would have thought that in those continents, we heard from Tata, that most of their customers at the moment are outside the area they come from, but those areas are looking at wireless to connect their people, particularly the poor ones. So with the engineers they have locally, sure, they're going to be looking at ways of delivering solutions from their side of things rather than looking towards the US and Western Europe. You only have to look at the way the likes of Samsung have knocked out, Motorola, Nokia, and Ericsson in the mobile space. I'm just wondering whether you're afraid that's the same thing's going to happen with the fixed line side over here.
Yeah, I mean, that's a very complicated question, but let me try. So obviously the networking market divides into many, many segments. You know, you have Ethernet on one side, you have LTE wireless on the other side that is dominated by very different vendors, by the way, right? Cisco was not successful as an LTE company, but it happens to dominate Ethernet. And, you know, vendors have an installed base, they have momentum, they build on that, they focus on it, they invest in that. There's high barriers to entry, either from a software or technology perspective, to be successful in any one of these segments. In the case of my company here, Arista, we focus just on the data center. Now, we looked at, wiring closets, other things, and said that's not for us because there's no growth there. HP is doing a great job. Like, this is, you have to look at this very narrowly to define how you even can get into the market. And it was this focus that allowed us as a new startup to become the #2 vendor now of 10 gig and above in the data center. But it takes an unbelievable amount of focus and attention to every single market segment to build the best product to win against the more established vendors. So it's open to other competitors, but it's not easy to get into this.
There's been innovation around the world. I don't see a lot of the innovation coming out of China right now. I see a lot of development of product and delivery of products and cost leadership. But if you look at the world, Europe has been the leader historically in cellular technologies, and so innovation isn't just coming from the United States. And I think one thing the network has done is created the death of distance. So where you are really isn't that important anymore. Innovation can come out of any place, and it's the culture. How do you create a culture that creates innovation? We had a panel on that earlier today. But it's not geographical, it's cultural.
And the other point to make is that if you look at the standards bodies, which define all the future networking standards, there is more and more participation from international companies. I mean, maybe 20 years ago it was dominated by Europe and the US, but look at any IEEE standard, you have companies from everywhere around the world contributing to these standards and taking their participation in these standards very seriously. So I think that will help to create standards that are amenable and adaptable for requirements that are unique to countries around the world. The standards are meant to be flexible, and then they will add options that will accommodate unique needs in different countries. So I don't think there's going to be an issue there. I think you will see international participation to drive these standards in the future.
I think we have time for one more quick one. Rick had one up front.
Thanks, and great panel. Rick Merritt with EE Times. So I guess I wonder, in the next big season of Ethernet, who's going to win? The Sharks with their ASICs or the Ducks with their merchant chips?
Merchant chips, triple odds.
We take part in both, thank you very much.
Yeah, they both have their roles.
I vote for merchant chips.
And we have a great partnership with Broadcom.
Great. Any last? I think we have 1 minute left. Great. Well, we have one down here. We do real quick.
So who is going to build the vertical appliance which are able to manage all the applications on the networks? Is it going to be HP or Cisco, or is it going to be the switch manufacturer like Arista? So the vertical appliance, is it a real market, and is it going to be quite embedded with the network?
I'll let you guys answer that.
You mean like the whole data center as an appliance, like server, storage, networking integrated?
Well, Well, we're
the monster box.
Yeah, so we're not creating a monster box. We've developed a philosophy around what we call converged infrastructure, and it's more than a philosophy. We do a lot of R&D work in this area, and the idea is to intelligently integrate technology in a way that allows a customer to then, spend less time on the infrastructure and just kind of maintaining it than versus doing other things like maybe innovating for their own company. So we do a lot of integration. If you look at our switching technology, we have switching technology integrated into our servers. We have switching technology integrated into our storage devices. I'm very comfortable with that. That's part of what the customers want. With regard to HP, though, we can also, and do all the time, exist in a completely heterogeneous environment. So they can, choose any one of our products and use it with others because of our standards.
Yeah, I would say there's an argument that the virtualization vendor, let's just call it, has some, defining role in managing everything underneath that layer. Now, it hasn't been quite delivered to the market this way yet, but it's logical to assume that things are in fact moving up and do abstract the underlying pieces more and more.
Great. Thank the panel for a great job.
Here we go.
And thank you to the panel, and thanks to Fritz for a great job. That's a tough one, nearly an hour and a half on stage. Well done, guys. Thank you very much indeed.